Siddhant has been working as an AI engineer for about 2 years now, and he currently works at Code Basics. So let's give a round of applause and welcome him to today's stage to give the lecture now.
Yeah, hi everyone. Hi. Uh, so let me share my screen and get started. But before I get started, I just want to know the tone of the audience here. So how many of you have already worked with AI agents or know the basic about it? I see. Okay, great. So we have a lot of people here who have used AI agents or uh, know a bit about it. Can you write in chat what frameworks you have used so far? LangChain, Google ADK, yeah, LangChain, etc. Okay, Google ADK. All right. So just give me 1 second. Uh, I'll share just one screen on my other screen and we'll get started. Okay. Uh, so anybody, how long do we expect to keep this session? Because I will uh, kind of deliver it in that way. So uh, if it is like 30 minutes or 1 hour, I'm really not aware about the time. Okay, 30 minutes. All right. So,
Sir, you can do it for 1 hour.
okay,
Yeah.
cool. So, yes. I hope everybody can see my screen, everybody can listen me clearly. So we'll
Yes,
get
sir.
started with this. Yeah. Uh, in 2025, Greg Brockman, who is this co-founder of OpenAI, he tweeted, right, that 2025 is going to be the year of AI agents. And it is very evident from the fact that we see a lot of companies in the industry who are adopting AI agents into their workflows or are creating some kind of agentic product of their own. So if you know Lovable recently, which was a platform to generate code using AI agent, uh, it crossed its 1 million ARR revenue with just 40 people on board. Similarly, OpenAI has launched Codex. Microsoft is internally creating AI agents for their team to automate processes, and it is also creating AI agents. It is also letting people create AI agents by using Office 360 Copilot, right? And you see, because of all of this, we see a rise in the total installs of all of these agentic AI frameworks like LangChain, Agno, Small Agent. So this graph that you see here is for small agents, and you can see the rapid rise, like from the beginning of Jan until the mid of May, right? So these frameworks, they let you create AI agents in a very minimal way. So they give you abstractions, right? And by using those abstractions, you can create AI agents. For example, here I have used Agno to create an agent for Wi-Finance, right? So it can call Wi-Finance tools and it can answer me certain questions like, okay, tell me how the stock of Apple is performing right now. All of these things that an LLM would not be able to do on its own, right? An LLM API would not be able to do on its own. But you see some problem here uh, with some framework like this. Anybody in the chat or wherever? Please feel free to speak up. Do you see any problem with this kind of approach where you have a framework that is abstracting out everything for you. And no one? All right. So the main fallback for this thing, like the main flow of this thing is you do not have a lot of control here, right? And apart from that, a lot of this is abstracted. So you don't know what's going on under the hood. And because of this, uh, I am a like big fan of Feynman, and he said once that what I cannot create, I do not understand, right? So if you do not know what AI agents are, uh, how they actually work internally, how the functions are being called on their own, right? We just have to define functions as tools, and they are being called on their own. So I was giving a similar lecture in one of the sessions, and people asked me like, how is an AI framework able to call some functions? How are these models able to do perform actions and all those things? And this is where I thought that I should create an AI framework for people who want to understand in depth. And because I'm creating this for education, it should not be more than 200 lines of code, right? So inspired by Small Agent, which is a framework by Hugging Face, which is around 1,000 lines long, uh, we created Small Agents, right? And in this session, we are going to cover what agents are, how these agentic frameworks work internally, and how to build a minimal agentic framework on your own. And we are also going to see how we can publish it on PyPy, right? So that you can install it via using pip install. So this like in this whole session, we'll see the whole journey of how we built this by also understanding how AI agents work internally, right? And mostly when you graduate and you join some industry and you're working on some kind of agentic applications, frameworks are not very appreciated. Sometimes you have to choose to write all the code, every logic on your own, custom build, because it gives you a lot of ability to customize the code, right? It gives you a lot of control. Uh, so let's get started by understanding what agents are. I've created a table here, and this will contain all the tools that you might be aware of. So the first one is RAG-based chatbot. Okay, so we'll define what agentic AI is by explaining the characteristics that it has. So the first characteristic is reactive. Anything which is reactive responds to your action. Okay, so if you prompt, it will respond. That's what a RAG-based chatbot does. Tool use means that it will be able to use some or the other tool or perform some kind of action, right? Then it's the reasoning, which means that the software that you're using or the tool that you're using should be able to reason and plan, right? And then there is proactivity, which means that so reactive and proactive are kind of antonyms. So reactive means when you act, the system will react. Proactive means you do not have to act, but the system will act on its own, right? So RAG-based chatbot that we see, RAG stands for Retrieval Augmented Generation. So you connect an LLM with a retrieval engine that retrieves some or the other document, and uh, it will generate output based on the document that it has retrieved. Then there is tool augmented chatbot, which these are chatbots which use tool. Now these are also reactive and have like tool using capability. An agentic system, on the other hand, will have the capability of plan and reason, right? So it will, if you give it some task, if it is vague, it will plan out the steps, uh, then see what tools it has uh, to use, and then it will act accordingly. So not all AI agents are proactive, but we have proactive AI agents as well. which will trigger based on some kind of event. Those are called event-based agents. Some tools, like some AI systems, will react based on a prompt, right? But proactive agents can also be scheduled, can also be triggered based on some kind of event that comes in. So, for example, a good example of a proactive agent would be an email responding engine, right? So, if you create an agent to take care of your emails, whenever a new email comes in, the agent will respond or categorize it into some kind of category, create a to-do list out of it, right? So these kind of agents will be called proactive. And reactive agents are tools like Lovable. So you give a prompt and Lovable plans, it outlines the steps to create an app, and then it will help you build that application by writing the code on its own by using some certain kind of tools. It will test the code and verify if the code is good, right? So all of these are characteristics of an AI agent. What goes on inside an AI agent, right? This kind of loop was a very early representation of what an agentic system will look like, right? And this is inspired, like this graph is also inspired by uh, agents that were trained using reinforcement learning in the early 1950s, right? So there is something called an agent, right, which has capability to act. Agent itself means something which has the capability to act or which has agency. Uh, so in an AI agent, there is something called an agent, which is a software, and there is an environment. So the agent will act, and uh, its action will bring some kind of change in the environment. The agent will then observe what change has happened in the environment and then act accordingly. So in an AI agent, uh, this kind of loop works. This is called a react loop, which means reasoning and action. So you send a query, the model will think and reason. It will see what tools it has with it, right? So it will use the tools, which means it will act, and it will see the output that the tools give. So it will observe, and this loop will go on until the end goal is achieved. Okay, so let's see. Uh, these are the core components that an AI agent should have. So let's see what components do we need to create for our framework to be an agentic framework. Okay, so the first thing that we see, oh, sorry, yeah. The first thing that we see here is the tool registry, right? It is some place where we store information about all our tools, and this will be used by our LLM. And when the model is going to think, reason, and iterate through multiple steps before reaching to a conclusion, it will need something like a step object. Okay, so the tool registry is used for storing the tools, and the step object is used to store the internal thoughts, the actions that it has taken, kind of a history of whatever has happened uh, throughout the execution of the agent. Uh, to store this, we need something like a step component. Then there is something called response parser. So many times these AI agents will respond with some kind of string, right? Because you see, an LLM is basically a model that generates text. But to implement or integrate that LLM with some kind of application, we need a very structured format like JSON, XML, YAML, or some other kind of format, right? So we have to create a parser that parses the textual output into some kind of JSON or any other object notation through which we can actually utilize what the output in our code, right? And then we need prompt formatter because we have to create a prompt, okay, that goes in and lets the model know that, okay, we have these tools. This is the prompt that the user wants. This is the end goal that the user is trying to achieve. And these are all the steps that you have taken before. So we wrap all of this by using a prompt formatter into a prompt. So I hope this part is clear to everybody, right? What a tool registry is, what steps are, what a response parser is, and what prompt formatter is. Okay. Only Ahem is answering. Anybody else? Okay. Good. If you have any doubts so far, feel free to ask. Ashish is here to help you with the doubts. And we will look into all of these components one by one. Okay. So let's look at the tool registry code first. So tool registry is nothing but it is a very lightweight manager for registering, retrieving, listing, and managing all these tools. Okay. And what are tools? Tools are functions that we give access to the LLM to, right? So these are the functions that will help us do something or perform some certain kind of action in our environment. So for example, the Y Finance tool that you saw, it helped the model to interact with the Y Finance API, right? So if you see this code, then uh, okay, uh, can somebody mute like if you do not have any question? Yeah. So let's look at the code here, right? If you see the init itself has a property which is tools, which is a dictionary of string and a tool object. We'll see what a tool object is in the next slide. But here, let's look at the registry first. So it is a dictionary which is a key value pair of the name of the tool and also the object of that particular tool, right? We have a register function that is adding any new tool into uh, the tool registry, which is self.tools dictionary, right? And then we have get and list method, which are pretty self-explanatory. But what is interesting here is this decorator that we have, right? We'll revisit this in the end. And this is all about the tool registry, okay? It is just a dictionary that stores all these tool objects uh, with respect to their names, right? And then there is the tool object here. In the tool object, we have all of these properties, which is name, function, description, and schema. So if you see, the function is a callable here. Uh, so I expect you to know like a bit of Python. So anybody of you, like, do you know what a callable is? Harshit, yeah. So LLM is the brain of an AI agent. Okay. So if I revisit this diagram, then the the think part, it happens in the LLM, right? So LLM is the brain of an AI agent. You, yes, uh, Ashish has answered. So yeah, let's look at the tool object here. So function is a callable. Anybody has any idea what a callable is? Okay, M does not know. Okay,
Is it like
so
we can call function using parentheses after defining it?
mhm, okay, yeah, we can call a function. So everything in Python is an object, right? So which means that it has some kind of properties and it has some kind of behaviors. Okay, so when I say callable, it means that the function itself in Python, it inherits from the callable class. So when you execute some kind of Python code, right, and when it gets interpreted, the function, when the abstract syntax tree is created for some kind of function that you define, it is of the type callable. Okay, it registers as the type callable because it can be called by uh, the parenthesis and passing some kind of uh, parameters or arguments, right? So we need a function here that our model will be able to call. So whenever our model says that, okay, I need to perform this action, we will be calling the respective function that is present in this tool object. Okay. We have self.name, which registers the name of the tool. We have self.function, which registers the actual function that we'll be calling when that tool is invoked. We have description. Okay. Now, why do we need description? Because we need to tell the LLM that, okay, this is what this particular function does. And if you have some kind of task that requires this kind of action, then please call this particular function. Okay, that is what the description will do. And then we have the schema. And what schema does is it defines what all parameters the function has. Okay, what arguments do we need to pass into that function for it to be called effectively. The interesting part here is the execute method. Okay, what this execute method will do is, you see, it is calling the self.function and passing the keyword argument. I hope you all know what quarks are, right? Uh, Folks, you have to respond to me, right, if you want to get the most out of this. Uh, right, right. So yeah, GK is right. It is dictionary arguments. Okay. So dictionary arguments means in quarks you can pass the name of the parameter, right? The name of the argument and the actual value of the argument. Okay. That is what quarks are used for, and these quarks can be represented in form of a dictionary. All right, which is why we are here unpacking these quarks. When we are calling the function, we are actually unpacking these quarks. Okay. If you are not certain about parameters, we use quarks. Uh, Actually, no. We have to be certain about these parameters. Why? Because see, here we are not certain what execute will receive. That is why we have used quarks. But in this particular function that you see, I hope like this is visible to you. Yeah. If you see in the function here, when I'm passing this, so this function should know what keyword it has. Okay, what all parameters it can accommodate, right? But in a parent function where it is called, which is this one, it is fine if we do not clearly specify what those exact keyword arguments are, because we have created a very generic class to represent a generic function or a generic tool. Okay. So this is what the execute method does. It will execute this function based on the parameters that are received by the LLM. So whenever in this loop, after the model thinks, so let's take an example, okay, to understand. Let's say I am using the same agent that I was using earlier, which is the Y Finance tool, and I asked it that, okay, show me the current stock price of Apple, right? Then this particular agent, it will have in the prompt itself, we will kind of write a system prompt, which will say that, okay, you are a finance agent. Your job is to help with all the finance related queries by using all of these tools. Okay. In the tools, we will write get current price. Okay. And in the definition, we will have that you need a stock ticker. So ticker is the symbol for that particular stock. For Apple, it is APPL. Okay. So the model will think, okay, that I need to fetch the current price. So I need to use this current price, get current price function. And how will it use that function? So it will give the name of that function and it will provide a dictionary of that function. I'm going to show you how the model generates it later in the slide. But just know that, okay, this is how model will always respond in form of text only. So after the execute, we have this string method. Okay. Anybody knows what this dunder string method does?
it like gives a description of that entire class. So whenever we like print just tool, then it will print the
Mm-hmm.
statement.
Right, right. So it converts that tool in form of a string. Okay, it represents that particular tool in form of string. Uh, so if you print it, right, this is what you will see. If you print just this tool object, this is what you will see. So yeah, great. Uh, Thank you, Revati, for the answer. So I think we have covered the tool registry part. So you have this list of tools, okay, and you have a tool class which contains all this information: name, function, description, and schema. Schema is basically the parameters that we need to pass, so the arguments that we need to pass. And then we have something called the steps class. Now this is where we store each attribute of the React loop. Okay, what are the attributes of the React loop? The attributes of the React loop are the thinking, the thought process, the action, the observation, and also like the query and the end goal, right? So we need to keep a track of all of these things. Why? Can anybody know? Can anybody tell me why we need to keep a track of all of this? Okay, so have you guys used any OpenAI API or any LLM API? I'm not talking about the chat itself, the chat interface. I'm talking about the LLM API. Have you used it? Yeah, cool. So have you ever noticed that every time you make a new call, the LLM remember what happened earlier? Have you noticed? Yeah. So which means that they won't save any kind of state every time they are called. So who has to save the state? A developer who is working with the API has to save the state. And guys, I'm sorry if I look distracted if I'm pointing like towards the screen. Actually, like I have casted the video here, so all the chats are visible to me on the screen. Okay, so uh, I'm still able to answer your question. So we need some kind of state to store whatever we have inferenced earlier, right? Because as I mentioned earlier, like if you see the agentic loop here, the React loop here, uh, then this is a multi-step process. This is not a single step process. So you cannot get the output for this in just one inference. You have to run it in cycles until the end goal is reached. So you have to save the state of all the previous actions that the model has taken so that the model doesn't repeat itself or hallucinates, right? So which is why we have this step object, which first of all saves the index. So okay, the number of steps that it is taking right now. So let's say the first step itself, in the first step itself, it will be 1, in the next step, it will be 2, and so on. And then it saves the thought. So whenever we prompt, we'll ask the LLM to reason about its actions or reason about its output, right? So it will save this thought here. If you see in this uh, components diagram as well, then we have to save the thought, action, action input, and observation, right? So the model, the framework itself, will store the thought here. And if there is any action, action will be saved here. If there is any input, so input is the argument that will be passing to this particular action. Okay. Uh, Action just means the tool that we call in. You see this tool, right? So this tool will become the action here. Okay. the tool will become the action here. So we are passing the name of that particular tool, which is why it is string here. So the step class has these methods, which is set action and set observation. Yeah. Do we have any doubt? Okay. So what we need to do is we need to pass these steps as well in form of the prompt. Okay, in the prompt we need to inject this particular uh, inject all the steps that we are taking into the prompt, which is why we have also defined the string method here. Okay, the dunder string method here. This will convert this particular list of steps, all of these steps, into a string so that we can pass it into the prompt and everyone can know that okay, these are the steps that I have taken so far. The next one is the response parser. So if you see, we are using all of these objects, right, to handle the state, the information, and the action in our agentic framework. So LLM will always respond in form of a string, right? And we can easily represent any kind of object in form of a JSON. So because of this, we are going to, yeah, and because of this, we are going to use this particular response parser, which will parse the text inputs into a valid JSON, right? And that JSON can be used uh, later on for whatever operation we need to perform. So if we need to call a tool, if we need to call, uh, sorry, if we need to add particular steps, so we can use this JSON parser for it. And then we have this prompt formatter, which is the final component in building an AI agent here. So if you see, this prompt component has only one method, which is format. And this is the system prompt that we are passing into the model. Just a second, guys. Yeah, sorry. Anybody has any doubt? I just saw a raise of hand. I think no. So, okay. So you see this prompt formatted here. Okay. You see this prompt formatter here, right? This will create a system prompt based on the history, the tool that we have, and it will set the tone for the AI agent. Okay. It will kind of ground it to generate only the kind of responses that we want for our framework to work. Now I have kept it very minimal here. So this particular prompt that you see is very minimal. And by the way, this whole framework is open source. So if you want to contribute into this framework, if you want to add some new features or whatever, feel free to add it. I'll send you the repo link in the chat later on. But we are saying it that, okay, you are an AI agent tasked with this particular task, which will be passed by the user. Okay, this is going to be the end goal for our agent. And then we are going to pass the tool list. Okay, you see this tool list, and because we have used formatted string here, the dunder str method will automatically be called. So the list of tools will get printed in form of the string that we created in the str method. And then we have this history, which is a list of all the steps. Okay, so just the earlier component that we see that we saw, it will also print all of this history. If no history is present, then it will say that okay, this is the first iteration. All right, And we are kind of enforcing it to generate only valid JSON uh, without any introduction, explanation, or additional text, right? So we want it to generate a JSON having all of these particular keys. And here in the brackets, we have mentioned what kind of output we want. Okay, we are describing the particular output that we want. So every time the model performs or takes any kind of step, it will respond in this format. So it will present a thought, it will take some kind of action, it will take an input, and it will respond with the final answer. So let's continue and see the whole structure of this repository, right? So the tool is called Nano Agents because it is very small, just 200 lines of Python code. And here I have this package, and I have added a small test class, and we are using poetry here. So I have added pyproject.toml file, which will manage our dependencies, manage what information will be present in our PyPy registry, all of that. And I think it's time that we look into the agent's code as of now. So far, what we have seen is we have seen uh, all of these components here, right? But this time we are going to see the core agent and how it works. So I'm going to take you to the repository now. Yeah, I hope my screen is visible. Okay, you can see the repository code. Yeah. So it is just one file, folks. If you want to contribute, feel free to contribute. Okay, I've tried to keep it very simple. So this is the final agent class. Okay, and here, whenever we are creating an agent, we are passing in the LLM that we want to use. So far, if you have seen any kind of, like, if you have used LangChain, Agno, whatever other framework, you have to call, like, use the LLM object that they provide, right? But that is an overhead for the framework itself, because you should be able to write, and all this particular agent wants is what input it should give to the LLM and what output the LLM gives, right? Both in the string format. So that is why I've taken this input as a callable of string and string, right? So I get the instruction in form of a string, and I get the output in form of a string, okay? Because that is what happens, right? When you prompt an LLM, what do? You send in a text and you receive some text back. So I've implemented that logic here, and the maximum number of steps that I want my model to perform actions for is 10, and I have 3 retries. So in case of any error occurs, the LLM will retry for 3 times before throwing an error. Okay. Then I've added the registry, which is the tool registry. I've created a class of tool registry, and I've created a class of response parser. So the LLM, the agent class has all of these 5 properties, which is the LLM, which is a callable, the max steps, the max retries, registry, and parser. Now I'm defining a tool function here. Okay. What this will do is this will register the particular tool that the model uh, wants, okay, to use or to perform any action. And I've created a add tool method. So this will be a decorator kind of thing. Okay. So you can do add the rate tool in on top of any function. You can use this tool decorator on top of any function, and it will automatically be registered into the directory via the decorator function that we saw earlier in the slides. And then there is the add tool method, which will manually, like this is like manually registering that particular function. Okay, so here you have more control. You are passing all the name, the description, all of those things, right? Then I have this execute with retry method. Okay, this will perform, like, attempt a particular iteration uh, at max for 3 tries, which is the default that I've given here. You can increase it to any number of tries that you want, and it will execute this particular whatever action that the model needs to take, right? So tool is synonymous to the action that it needs to take. And then we have this retry with retry LLM, which will generate all of the text that we need. And if you see here, we are taking it, we are calling the LLM with our prompt. So your previous response was incorrect, responding the correct one. So if any error occurs, right, while during the step of the agent, this is what it will do. It will give it the error, and it will give it the prompt that we earlier gave, so that the model corrects itself, tries to correct itself at least. And then we have this run class. This is the main class that you will run, where you will pass the task. So the main user of our repository will be using this particular function, and this will put everything in action. All of the things that you saw earlier, it will put it in action. So if you see the steps here, I am iterating for the maximum number of steps, which is 10. I've kept it 10 here, but you can change it to whatever number you want. Okay. And then it will create the final prompt. So it will stuff all the things. What will it stuff? It will stuff all the tools that the model has, all the steps that has happened so far. In the first iteration, there will be no steps, and the final task that it needs to achieve. Based on this function, it will see the iteration, right? This is just a log for visibility purpose, for observability purpose, that okay, what is happening in the agent. What we are doing is we are extracting the think part, right, from here, and everything except the think part we are taking as uh, the LLM response, and then we are printing what response we have gotten from the LLM. We are parsing this output in form of a JSON, and we are calling it a response dictionary. So the response parser that we saw earlier, so this response parser, it has a method called parse, right, which will convert the string output that we get from the model into a JSON response. So it will create a response dictionary, right? After we load that JSON response, it will become a dictionary, and from that dictionary we are getting all of these things, like thought, we are getting thought, action, and final answer, all of these things. If any of these things are not present in the LLM response, if any of these things are not present in the LLM response, we are using this retry with LLM method, right? So that the LLM corrects itself, and then we are increasing a step, and we are adding that step in our history. And if we achieve final answer, then we are returning the final answer, right? If we have an action, then we are looking for inputs, and we are loading these action inputs, which will be a dictionary. And in self.registry.get action, the action itself will be the name of that particular tool, right? And if you see the tool registry, it saves the name with the whole tool. So when I say get action, which is the name of the particular tool, it will fetch the whole tool for me, which is why we are saving it in this tool variable, and we are executing that particular tool with retry using this particular function that we saw earlier. I know this could be too much, right? So you can ask me if you have any query, or you can just take your time, go through this particular repo. You can have my LinkedIn profile, or you can create an issue itself in this repository if you have any doubt and if you want to understand. So folks, I've created this for educational purposes only, not for using in production or creating some apps out of it. So if you have any doubt, feel free to reach out to me through any of the channels. So we will execute using this execute with retry, and then in the step we are setting the action and we are setting the observation of that particular action. Okay, so this is how we have created the whole nano agent framework. Let's see how it is being used here. So here, if you see, then I do not need to import anything except the agent class. Okay, I just need to import the agent class. Once I import the agent class, I can import any of my favorite LLM SDK to connect with any API, right? I can use OpenAPI, I can use OpenAI, Gemini, Grok. Okay, I use Grok because it is free to use and it has a lot of open source LLM options. And I can define my callable here. So this is a callable, all right? It is a simple function which takes a string and returns a string. And here my logic could be anything. Okay, it depends on the user. If you are using some kind of custom LLM, right, which is in-house, then you can also define this particular function. All you need to make sure is it takes in a string and returns a string, and that your model is good enough to create the JSON that we want. So I create the agent class and pass in the LLM here. Okay, and internally the agent class itself is calling the tool registry. It is calling all the other components that it wants. It is creating an object for all of them, right? Then I can use this tool decorator to create my tool. What I need to do is, what is completely compulsory is that I pass in a description here, right, in form of a doc string. So this doc string will be appended as the description of this particular tool, and later it will be passed on as prompt while invoking the LLM. And then I will call the run method that I just called, and I will see the result, right? So this was whole process of building our own agentic framework, right? Now, if you want me to show you how to publish it into PyPy, I'll share it with you via the slides. Okay. So to manage the whole uh, repository, the package, I've used something called Poetry. And Poetry is a package manager. Uh, it is like pip but on steroids, right? So it has all of these cool features of um, helping you publish the repository, manage a lot of different dependencies. Uh, it has a single file that can manage your dependencies for different stages of development. Like you can manage dev dependencies, production dependencies, or test dependencies, right? So we'll look briefly into how to publish our library into PyPy so that anybody can install it using pip. You need to create an API token first in the PyPy repository, right? So you have to go into PyPy, and in PyPy, you have to log in as a user. You can use your GitHub ID to log in, and after you have logged in, you have to go to your account and create this API token, right? Once you have created this API token, you can enter this particular command, which is poetry config pypy then token dot pypy, and you can add the token that you copy from here. Once you have copied that particular token, you need to write poetry publish, and then you need to add dash dash build here, right? Here I have assumed that I have already created a build. So build is like binary of that particular file. when you write poetry build, it will create a binary of that Python object, which means that it will compile it into kind of what would I say, kind of an object code, and it will create a binary out of it. Now that binary can be published anywhere, and it can be used by using PyPy. Okay, and then you can write poetry publish. It will publish your repository into your GitHub. So thank you. I'm here from Code Basics. We are a YouTube channel, and we educate you on AI, data science, and data analytics. So you can check out the YouTube channel from here. And that's it from my end. If you have any questions, feel free to open your mic. I'm still here for a few minutes. So how many of you think that Nano Agent requires more feature? Raise your hand. So we do not have any inbuilt tools, right? We do not have memory for our agent. We do not have a lot of things. So how many of you think we should add all of those things? Yeah. So I would ask you all to contribute as well, create issues, right? Keep the repository active. I'm sharing the link of the repository here if you want to check it out on your own. Currently it is in my personal ID, but we are going to shift it, migrate it to the Code Basics GitHub. So feel free to contribute as well, and do check out the repository, try it out. If you have any questions, you can reach out to me or Ashish via our LinkedIn. If you want, we can share the URL as well with you. So if you have any doubts, you can ask it now.
Thank you, Siddhant, for such an insightful session. You really showed us how to experiment and build this ourselves, which is honestly the best form of learning. And we are truly grateful to you and Ashish for sharing your time and expertise here. And also a big thank you to everyone who joined us here today to keep the session a little interactive. Well, we have another session, third session on 15th November. So I hope you guys also join us on that day. It will be pretty interactive and informative as well. Once again, thank you guys.
Yeah, thank you for having me, everyone. Bye.
Thank you, sir.